Electromagnetic waves. Electromagnetic waves are all transverse waves and involve oscillations in electric and magnetic fields. Visible light is an electromagnetic wave. All electromagnetic waves travel at the same speed in a vacuum and in air, and this is known as the speed of light. They can travel through a vacuum, unlike sound waves. This speed is incredibly fast, 300 million meters per second, which is usually written as 3.0 times 10 to the 8 meters per second, meaning 3 with 8 noughts after it. This is fast enough to travel almost 8 times around the Earth in 1 second. The other electromagnetic waves are radio waves, microwaves, infrared, ultraviolet, X-rays and gamma rays. They form a continuous spectrum called the electromagnetic spectrum. Here we have a chart giving the whole of the electromagnetic spectrum in order of wavelength and frequency. Radio waves with a wavelength of around 10 to the 3 meters, 1,000 meters or a kilometer, and a frequency of 10 to the 4 or 10,000 hertz, 10,000 cycles per second. Going along, eventually we get to gamma rays with the shortest wavelength, around 10 to the minus 12 of a meter, which is around 100 times smaller than an atom, to a frequency of 10 to the 20 hertz, one with 20 noughts after it, cycles per second. As we go in this direction, we have reducing wavelength, increasing frequency, increasing energy, and increasing danger. A source of energy produces electromagnetic waves that then transfer that energy until some object absorbs the energy. For example, a radio transmitter produces radio waves that can be absorbed by a radio receiver, what we just call a radio, or by a television. Here we have a radio transmitter, and the radio waves are produced by moving a charge, in this case an electron, up and down the transmitter. That produces an electromagnetic wave which will travel out. When it reaches the aerial of the receiver, it will again make charges go up and down, giving the signal, something like this. A microwave oven produces microwaves. These are then absorbed by the food, which raises the temperature. The microwaves cause water molecules throughout the food to vibrate, so they heat the food faster than a conventional oven that only heats the food from the outside. They use microwaves of wavelength around 12.2 centimeters. So here we have a microwave oven containing a pie, and I've drawn in 3 water molecules. This is the device that produces the microwaves, and as the microwave passes through, it makes the water molecules vibrate, which will then heat up the food around it. Mobile phones use the production, transfer and absorption of microwaves to send and receive signals. Mobile phones use lower energy microwaves than ovens with a wavelength of just under 30 centimeters. Microwaves are also used by radar systems that track the position of aircraft. They are also used to communicate with satellites. A hot object, such as a grill, produces infrared radiation that heats the food, which absorbs that radiation. You're not seeing the infrared here. The grill also gives off a small amount of visible red light. TV remote controls produce infrared light, which is absorbed by the sensor in your TV. Try looking at the emitter in the end with a mobile phone camera. As you press a button on the remote control, you may see something like this. Some are sensitive to infrared, and so you can see an image on your phone. You're not actually seeing the infrared here, just the response of your camera. Very hot objects, such as light bulbs and stars, produce visible light, which can be absorbed by our eyes or by the sensor in a camera, so allowing an image to be produced. A tanning lamp produces ultraviolet light, which when absorbed by the skin causes the production of pigment. Sunscreen absorbs or reflects ultraviolet light to prevent it causing premature aging or even skin cancer. Photocopy paper contains chemicals that glow when they absorb ultraviolet light. The The sun emits ultraviolet light, and so it makes the paper look bright in sunlight. Banknote paper doesn't contain these chemicals, so does not glow. Here we have a normal banknote on a normal piece of photocopy paper, but being lit by an ultraviolet light. You're seeing visible light given off by the chemicals in the paper here. You can't see the ultraviolet light. You see that the photocopy paper is glowing, the £20 note is not. An X-ray machine produces X-rays. When these are absorbed, they can produce an image on photographic film. They can pass through soft tissue, but are absorbed by bone, so this shows an image of the bones. X-rays are also used to kill cancerous cells in the process known as radiotherapy. Radioactive isotopes can produce gamma rays, which when absorbed by cancerous cells and healthy cells can destroy them. Isotopes which emit gamma rays can be used as radioactive tracers. They can be injected into the body, and the gamma rays detected outside of the body. This allows us to trace the path of blood around the body and perhaps highlight medical problems. X-rays and gamma rays are both what are called ionizing radiation. They can damage cells and can cause them to become cancerous. The dose a person receives is measured in units called millisieverts, and this has to be minimized and monitored for their safety. Both X-rays and gamma rays have similar wavelength and frequencies, but X-rays are produced by firing high-speed electrons at a metal target. Gamma rays are emitted from the nucleus of an unstable atom. Hence you may have heard the term nuclear radiation, radiation from the nucleus. When you have an X-ray at a hospital or at the dentist, the operator will leave the room, so they're not subjected to unnecessary danger.